Hello everyone, welcome back to my channel. I'm Nandini. Today I'm going to discuss about an undecidable problem, that is RE, under the subject Automated Theory and Computation. Let us briefly discuss about this. Introduction to undecidable problems. An undecidable problem is a computational problem for which it is impossible to create an algorithm that always leads to a correct yes or no answers. This concept, rooted in a field of computer science, challenges the limitations of a computer computation and has profound implications for the understanding of the boundaries of what is calculable. Undisability is typically associated with problems related to formal languages, automata theory, and logic, and the exploration of undecidable problems has led to the significant advancements in the theoretical computer science. Next is the definition of RE, that is recursively enumerable problems. In the field of theoretical computer science, RE, recursively enumerable problems, refers to a unique set of decision problems and that can be enumerated by a Turing machine. This means that there exists an algorithm such that if a given input satisfies the problem's criteria, the algorithm would eventually halt and accept, providing a positive instance. However, in case of a negative instance, the algorithm may run indefinitely without halting, thus not providing a conclusive answer. The concept of RE problems is closely linked with the concept of semi-disability, where a language is semi-disable if there exists a Turing machine that will accept the strings in the language and either reject or loop indefinitely on strings not in the language. This critical distinctions lays the foundation for the study of undecidable problems and their characteristics. Next, let us see the explanation of undecidable problems, that are RE. Definition: undecidable problems that are recursively enumerable are the class of problems in computer science that can be recognized by a Turing machine of a yes, answer is yes, but may not alter provides an answer if input is not in the language. This means that there might not be an algorithm to determine if the input is valid or not. Next is a characteristics. These problems exhibit a semi-decidable nature where they can be recognized but not necessarily decided in a finite amount of time. Their properties can be proven using computation models like Turing machines or other equivalent formalisms. Scope: the study of undecidable problems, that are RE, is crucial in understanding the limits of computation as well as the boundaries of algorithms. Encompasses the various complexity theory, formal languages, and algorithm insights into a inherent complexity and certain computability. Next is an example of undecidable problems, that is ARC-RE. First is a Turing machine acceptance problem. The Turing machine acceptance problem is a classic example of an undecidable problem that is also recursively enumerable. It involves determining whether a given Turing machine, when started on a blank tape, will eventually halt and accept its input. Post correspondence problem. The post correspondence problem is another undecidable problem that falls into the category of recursively enumerable problems. It asks whether a set of strings can be arranged into a sequence where the concatenation of the strings matches. And this problem is RE because a Turing machine can be designed to essentially guess and check all possible configurations of the strings to see if a matching sequence can be found. Next is a halting problem for two tape Turing machines. This variant of the halting problem involves determining whether a two-tape Turing machine, when given an input, will eventually halt. Like the original halting problem, this is an undecidable problem that lies with the realm of recursive enumerable problems. Next, let us see briefly about the halting problem as an example. Computational complexity. The halting problem serves as an example of a computationally complex challenge in computer science. It highlights the intricate nature of determining whether a program will halt or run indefinitely. Infinite loops. An image depicting an endless loops symbolizing the problem of identifying whether the program will enter an infinite loop or terminate successfully. The image captures the concept of an endless and repeating process in a visually compelling way. Unsolvable decision problem. Illustration of a perplexed problem surrounded by a multiple paths, showcasing the idea of an unsolvable decision problem. The image conveys the complexity and dilemma associated with the making decisions when the it with undecidable scenarios. Next is the characteristics of undecidable problem that RE. Complexity. Undecidable problems that are recursively enumerable often exhibit immense complexity. They involve intricate patterns, dependencies, and interactions, making them challenging to decipher. The complexity of these problems stems from their behavior and underlying concepts required in through analysis and exploration to understand their nature. Next is a partial solutions. One characteristics of undecidable problems that are um, RE is the existence of a partial solutions. While these problems may not have a definite yes or no answer, there might be ways to appropriate solutions or identify specific patterns within the problem space. The duality of uncertainty and partial clarity adds depth to the study of these problems. Non-deterministic nature. Undecidable problems in a RE category often manifest non-deterministic behavior, where the outcomes may vary based on different inputs or conditions. This determinism introduces unpredictability and intricacy, requiring specialized approaches and methodologies to navigate through the problem-solving process. Next is the importance and relevance of studying undecidable problems that are RE. Bridging theory and practice. Studying undecidable problems that are recursively enumerable provides a bridge between theoretical concepts and practical applications in computer science. Boundary of computation. Understanding undecidable problems in the RE class delineates the boundaries of what is computality feasible. It highlights the inherent limitations of algorithm and computation. Algorithmic innovations, exploring undecidable problems that are RE, stimulates the development of novel algorithmic approaches and computational uh, paradigms, and it encourages innovation. Ethical and social implications, and analyzing undecidable problems in the realism raises ethical and societal considerations regarding the impact of computational limitations and privacy, security, and artificial intelligence. Challenges and limitations in solving undecidable problems that are RE. Complexity of solutions. One challenge in solving undecidable problems that are recursively innumerable RE is a complex of finding solutions. These problems often require extensive computational resources and intricate algorithms, make it difficult to arrive at the definite solutions within a reasonable time frame. Next is inherent ambiguity. And undecidable problems that are RE are inherently ambiguous, leading to the challenges in formulating precise and unambiguous problem statements. This ambiguity contributes to the complexity of devising effective strategies for solving these problems. Resource constraints. Other limitation is a constraints on computational resources and memory, especially when dealing with undecidable problems that are RE. These constraints can hold the exploration of potential solutions and impede the true examination of problem spaces. Evolving problem landscapes. Undecidable problems within a realm of RE exhibit evolving problem landscapes where the complexity and characteristics of a problem can change over time. This dynamic nature process challenging developing static solution approach. Next, let us see the conclusion and key takeaways of the undecidable problem. As we conclude our exploration of undecidable problems that are recursively enumerable, it's important to reflect on the key takeaways from our discussion. One of the most significant insights is the profound impact of undecidable problems on computer science and mathematics, challenging traditional notions of solvability and computation. Furthermore, our journey has highlighted the pivotal role of undecidability in shaping the theoretical and practical aspects of algorithmic complexity and formal language theory. The RE problems with undecidability has opened new and research and exploration in the field. Thank you for watching. Please do like, share, and subscribe.